So how might we define a dilation? Does anybody have any like ideas for it? Go ahead, Gavin Hart.
A change in the size of the side lengths.
Okay, good, and I like that. It's a change in the size of a figure, but does the shape of the figure change? Okay, so what we're going to say is this is a transformation that changes the size of a shape um, and let's say by an amount called the scale factor. But does not change the shape. And that might be a confusing way of saying it just because we're using shape twice. So maybe a better word here would be figure. Changes the size of a figure but does not change the shape. Okay? For some reason it's lighter when my hand gets in there. Does not change the shape. What we need to have then is a somewhat better understanding of what a scale factor is and how this affects things. Okay, so we need to talk about a scale factor. And while we're at it, let's define this real quick. Um, the pre-image. How would we say? How would we describe a pre-image? Pre-image is what, Gavin Newman?
The image before it gets altered.
Yeah, good. And we're just going to say it in common language terms here. The original shape. So it's where we start, and then the image is what? Phillips?
The aftershape.
Yeah, the after shape. It's like a before and after, right? You guys have seen those transformation pictures, right? The after shape. It's all right. I've got a couple flexing on them, you know. Okay. Pre-image is the original shape. The image is the shape after the transformation has occurred. Okay, let's talk about this scale factor then. What is a scale factor and how does it affect what we do? Gavin Hart.
I think it's like the number that you multiply the x and y values by.
Yeah, good. Okay, and that's a pretty good layman's terms definition. Okay, so this is like we'll write that because I like having that in here. The number we multiply the coordinates by. Okay, but let's get a little bit more formal here as well. Yes, this is what we see the scale factor as, but what is a scale factor? Donovan?
The factor that you multiply by to get the image.
Okay, yeah, you're correct. And again, that's just multiplying numbers. I want to get at the heart of what a scale factor is. And what we're actually looking for here, and maybe I'll write it in red, is that a scale factor is really a ratio of, let's call it of measures of the image to measures of the pre-image. Okay, I don't know if that's hard to see for you guys. Is that hard to see? Can you get that? A ratio of measures of the image to measures of the pre-image. So what we're looking at here is actually a fraction. It's the image over the pre-image. Okay. Now we can come up with some different things here, and let's talk if a scale factor. We're going to call a scale factor k. Okay, this is just what we refer to it as. We don't like s's because they look like fives, and we don't need anything like c's. Okay, so we're going to call our scale factor k. That's the variable we're going to use to decide it. How do I know, based on the scale factor, if the image gets bigger or smaller? So is it a growth? Does the figure get bigger? Does it grow or shrink? For what values of k, so for what scale factor values will this grow? Donovan? Would it grow that way? It would shrink that way. So, K. Nielsen, when would it grow? Yeah. So our K value simply must be greater than 1, and it'll be a growth. Because if the fraction is bigger than 1, the number I'm multiplying will get bigger, right? Let's not forget that this is just the number I'm multiplying by. When will it shrink? Juliana? When k is less than 1. And let's be a little specific here. When k is less than 1, you're right. But what I don't really want to happen is I don't want negative values either. So we'll just say when k is between 0 and 1. Okay, that is when we'll see some growth and shrinking happen. Real quick, let's go over. Do you have a question? No? All right. Let's talk about some properties of dilations. Here we go. What are the things that dilations preserve? Kay Nielsen. Good. It preserves orientation. What else does it preserve? Newman. The angle measures. Who's this?
You got my money?
Oh, you're being recorded, dude. What else does it preserve? It preserves angle measures and Landon? Okay, shape. And yeah, these are all the things that preserve shape, right? The orientation and angle measures. But you're not wrong. It preserves shape, and there are a couple aspects of shapes that we need to have. Okay, let's talk about this, and let's do an example of this one. It preserves collinearity. What does it mean to be collinear? Collinear. Oh, geez, Ben. Muffled that one up. This is an I. Collinearity. Collinearity. What does it mean to be collinear? So collinear here means on the same line. So if 2 points start on the same line, when we dilate them, they'll end on the same line. Does that make sense? Okay, so we've got another thing that comes off of that. This also preserves what we call betweenness. What do you think betweenness means? B. Betweenness just means this. It means the order stays the same. And how nuts would it be if it didn't? All right, and then we've got this last property of dilations. The ratios, also known as the scale factor, the ratios of lengths of corresponding sides are equal. Can you guys still see that? Is that up there? There we go. The ratios of corresponding sides is equal. Well, that one kind of says no duh as well, right? If I multiply one side of the shape by a scale factor, I'm going to multiply every side of the shape by the scale factor. Okay, let's pause. Okay, so we've got two shapes, and we're going to look for the scale factor, and how do we find the center of dilation? Well, to find the scale factor, what ratio do we use? Newman? Close. It's the image, and I probably should have specified this, over the pre-image. So if I call this A, B, C, and D, this would be A prime, B prime, C prime, and D prime. So this is my pre-image. This is my image. And maybe that changes your answer now, Gavin. Go ahead and fix it for us. What is the length of the image? 21. The corresponding side in the pre-image is what? 7. This means my scale factor is 3. So if side CD started as 5, what would it end up as? 15. Okay. Now, we also need to understand this small little thing about the center of dilation. Okay. And let's say it like this. The center of dilation is found by, and let me show you how it's found, and then we'll talk about how to word it. To find the center of dilation, I take a ruler through A and A prime. Let's see if my center shows up. Then I go through B and B prime. And then C and C prime. And they should have all intersected at one point, but clearly my image is not an accurate dilation. Okay, they should intersect at the same point. So let's see if D gets close. It's good to split the stinking difference, isn't it? It's all right. If this was an accurate image or an accurate dilation, the intersection would be the center of dilation. So if we had done this on a graph, it would have been better, but that's okay. The center of dilation is found by drawing lines, through corresponding vertices. It's found by drawing lines through the corresponding vertices and is the intersection. Okay.